How to create a black hole out of thin air. Black holes were thought to arise from the collapse of dead stars. But a Webb telescope image showing the early universe hints at an alternative pathway. How many ways are there to leave this universe? Perhaps the best-known exit entails the death of a star. In 1939, the physicist J. Robert Oppenheimer and his student Hartland Snyder, of the University of California, Berkeley, predicted that when a sufficiently massive star runs out of thermonuclear fuel, it collapses inward and keeps collapsing forever, shrink-wrapping space, time and light around itself in what today is called a black hole. But it turns out that a dead star might not be needed to make a black hole. Instead, at least in the early universe, giant clouds of primordial gas may have collapsed directly into black holes, bypassing millions of years spent in stardom. That is the tentative conclusion recently reached by a group of astronomers studying UHZ-1, a speck of light dating from not long after the Big Bang. In fact, UHZ-1 was a powerful quasar that spat fire and X-rays from a monstrous black hole 13.2 billion years ago, when the universe was not quite 500 million years young. That is unusually soon, cosmically speaking, for so massive a black hole to have come into being through stellar collapses and mergers. Priyamvada Natarajan, an astronomer at Yale and the lead author of a paper published in the astrophysical journal Letters, and her colleagues, contend that in UHZ-1 they have discovered a new celestial species, which they call an overmassive black hole galaxy, or OBG. In essence, an OBG is a young galaxy anchored by a black hole that became too big too fast. The discovery of this precocious quasar could help astronomers solve a related puzzle that has tantalized them for decades. Nearly every galaxy visible in the modern universe seems to harbor at its center a supermassive black hole millions or billions of times as massive as the Sun. Where did those monsters come from? Could ordinary black holes have grown so large so fast? Dr. Natarajan and her colleagues propose that UHZ-1, and so perhaps many supermassive black holes, began as primordial clouds. These clouds could have collapsed into kernels that were precociously heavy, and were sufficient to jump-start the growth of overmassive black hole galaxies. They are another reminder that the universe we see is governed by the invisible geometry of darkness. As the first OBG candidate, UHZ-1 provides compelling evidence for the formation of heavy initial seeds from direct collapse in the early universe. Drive. Natarajan and her colleagues wrote. In an email, she added, "Nature does seem to make BH seeds many ways, beyond just stellar death." Daniel Holes, a theorist at the University of Chicago who studies black holes, said, "Priya has found an extremely exciting black hole, if true." He added, "It is simply too big too early. It's like looking in at a kindergarten classroom and there among all the 5-year-olds is one that is 150 pounds and or 6 feet tall." Your free account gives you access to many of our newsletters. According to the story that astronomers have been telling themselves about the evolution of the universe, the first stars condensed out of clouds of hydrogen and helium left over from the Big Bang. They burned hot and fast, quickly exploding and collapsing into black holes 10 to 100 times as massive as the Sun. Over eons, successive generations of stars were formed from the ashes of previous stars, enriching the chemistry of the cosmos. And the black holes left over from their deaths kept merging and growing somehow, into the supermassive black holes at the centers of galaxies. The James Webb Space Telescope, launched 2 years ago this Christmas, was designed to test this idea. It possesses the biggest mirror in space, 21 feet in diameter. More important, it was designed to record infrared wavelengths from the light of the most distant and therefore earliest stars in the universe. But as soon as the new telescope was trained on the sky, it caught sight of new galaxies so massive and bright that they defied cosmologists' expectations. Arguments have raged for the last couple of years about whether these observations in fact threaten a long-standing model of the cosmos. The model describes the universe as composed of a trace of visible matter, astounding amounts of dark matter, which provides the gravity to hold galaxies together, and dark energy, pushing these galaxies apart. The discovery of UHZ-1 represents an inflection point in these debates. In preparation for a future observation by the James Webb Space Telescope of a massive cluster of galaxies in the constellation Sculptor, Drive, Natarajan's team asked for time on NASA's Chandra X-ray Observatory. The cluster's mass acts as a gravitational lens, magnifying objects far behind it in space and time. The researchers hoped to get a glimpse in X-rays of whatever the lens might bring into view. What they found was a quasar powered by a supermassive black hole about 40 million times as massive as the Sun. Further observations by the Webb telescope confirmed that it was 13.2 billion light-years away. The Sculptor cluster is about 3.5 billion light-years away. It was the most distant and earliest quasar yet found in the universe. We needed Webb to find this remarkably distant galaxy, and Chandra to find its supermassive black hole, Akash Bogdan of the Center for Astrophysics Harvard and Smithsonian said in a news release. We also took advantage of a cosmic magnifying glass that boosted the amount of light we detected. The results indicate that supermassive black holes existed as early as 470 million years after the Big Bang. That isn't enough time to allow the black holes created by the first generation of stars, starting out at 10 to 100 solar masses, to grow so big. Was there another way to make even bigger black holes? In 2017 Drive, Natarajan suggested that collapsing clouds of primordial gas could have birthed black holes more than 10,000 times as massive as the Sun. You can then imagine one of these subsequently growing into this young, precociously large black hole, Drive. Holes said. As a result, he noted, at every subsequent time in the universe's history there will always be some surprisingly large black holes. Dr. Natarajan said, the fact that these start out in life overmassive implies that they will likely eventually evolve into supermassive black holes. But no one knows how that works. Black holes make up 10% of the mass in the early quasar UHZ-1, whereas they compose less than 1/1000% of the mass of modern-day galaxies like the giant Messier 87, whose black hole weighed in at 6.5 billion solar masses when its picture was taken by the Event Horizon Telescope in 2019. That suggests that complicated environmental feedback effects dominate the growth and evolution of these galaxies and their black holes, causing their mass in stars and gas to bulk up. So in effect these extremely early OBGs are really telegraphing much more information about, and illuminating, seeding physics rather than later growth and evolution, Drive. Natarajan said. She added, though they have important implications. Dr. Holes said, it would certainly be cool if it turns out to be what's happening, but I'm genuinely agnostic. He added, it's going to be a fascinating story no matter how we solve the mystery of early big black holes. First detection of an overmassive black hole galaxy UHZ-1. Evidence for heavy black hole seed formation from direct collapse. The recent Chandra JWST discovery of a quasar in the Z=10.1 galaxy UHZ-1 reveals that accreting supermassive black holes, SMBHs, were already in place 470 million years after the Big Bang. The Chandra X-ray source detected in UHZ-1 is a Compton-thick quasar with a bolometric luminosity of L-tilde 5 times 1045 erg-1. Which corresponds to an estimated BH mass of tilde 4 times 107 m circled operator assuming accretion at the Eddington rate. JWST NIRCAM and NIR spec data yield a stellar mass estimate for UHZ-1 comparable to its BH mass. These characteristics are in excellent agreement with prior theoretical predictions for a unique class of transient, high redshift objects, over massive black hole galaxies, OBGs, by Natarajan et al., that harbor a heavy initial black hole seed that likely formed from the direct collapse of the gas. Based on the excellent agreement between the observed multi-wavelength properties of UHZ1 with theoretical model template predictions, suggests that UHZ1 is the first detected OBG candidate. Our assertion rests on multiple lines of concordant evidence between model predictions and the following observed properties of UHZ1. Its X-ray detection and the estimated ratio of the X-ray flux to the IR flux that is consistent with theoretical expectations for a heavy initial BH seed, its high measured redshift of Z equals 10.1, as predicted for the transient OBG stage, 9 less than Z less than 12, the amplitude and shape of the detected JWST spectral energy distribution, set between 1 to 5 microns, which is in very good agreement with simulated template SEDs for OBGs, and the extended JWST morphology of UHZ1 that is suggestive of a recent merger, also expected for the formation of transient OBGs. As the first OBG candidate, UHZ1 provides compelling evidence for the formation of heavy initial seeds from direct collapse in the early universe. Darkness visible. Finally, astronomers capture first ever image of a black hole. Astronomers at last have captured a picture of one of the most secretive entities in the cosmos. Astronomers announced on Wednesday that at last they had captured an image of the unobservable, a black hole, a cosmic abyss so deep and dense that not even light can escape it. For years, and for all the mounting scientific evidence, black holes have remained marooned in the imaginations of artists and the algorithms of splashy computer models of the kind used in Christopher Nolan's outer space epic, Interstellar. Now they are more real than ever. "We have seen what we thought was unseeable," said Shep Doeleman, an astronomer at the Harvard-Smithsonian Center for Astrophysics, and director of the effort to capture the image, during a Wednesday news conference in Washington, D.C. The image, of a lopsided ring of light surrounding a dark circle deep in the heart of a galaxy known as Messier 87, some 55 million light-years away from Earth, resembled the Eye of Sauron, a reminder yet again of the implacable power of nature. It is a smoke ring framing a one-way portal to eternity. To capture the image, astronomers reached across intergalactic space to Messier 87, or M87, a giant galaxy in the constellation Virgo. There, a black hole several billion times more massive than the Sun is unleashing a violent jet of energy some 5,000 light-years into space.